Today's lesson is on prime factorization. Prime factorization is writing a composite number as a product of prime numbers. So since we're using this word product, that means we will include the multiplication symbol in our answer. Sometimes today when we find our prime factorization, we will see some numbers repeated. We're going to make sure we learn to use an exponent to show these repeating numbers. 2 times 2 times 2 can be written as 2 to the third power. We could also call that 2 cubed. A common mistake that many students make is they'll look at this and try to work it out by saying 2 times 3. That is incorrect. 2 times 2 is 4, and then 4 times 2 is 8. There are two methods to use to solve for prime factorization. The first method I would like to show you is called the tree. You take any composite number. You're going to choose two numbers to multiply together to get that composite number. The neat thing about using the tree is you can pick any two numbers, any factor pair that you can multiply together to make 84. So I chose 3 and 28. Someone else might have chosen something different, maybe something with a 2, since this is an even number. That would work too. We're just going to try it with 3 and 28. So I circle the 3 because it's prime. I do not have to do anything else with the 3. We will not break it down into 3 times 1. When you're doing prime factorization, you will never use a 1. All right, now let's look at the 28. All right, when I think of 28, I think of the factor pair 4 times 7. Again, there are other options. 28 is divisible by 2. We could have used that. But anyways, 4 times 7 will give us 28. The 7 is prime, so I circle it. We're done with that 7. The 4 is composite, so we'll break the 4 into 2 times 2. When all of the numbers are prime numbers, you have found the prime factorization. Now we just have to rewrite. It'll normally be written in order from least to greatest. 2 times 2 times 3 times 7. 2, 2, 3, and 7. Then we will simplify by combining these two. There are two number 2's, so that is 2 squared times 3 times 7 for our final answer. Let's try it out. We're going to use the tree method to find the prime factorization of the number 36. So I start with the number 36. Now I'm going to draw two branches, and I need two numbers I can multiply together to get 36. I automatically think of 6 times 6. There are other options, but this is what we'll use on this time. 6 is a composite number, so I won't circle either one of these. I'm going to continue my tree with branches. Okay, I can get 6 by multiplying 2 times 3. 2 and 3 are both prime, so I will circle them. Now for this 6. Again, 2 times 3. We'll circle both of these as well. Everything circled. I found my prime factorization. Let's rewrite. 2 times 2 times 3 times 3. 2 number 2's and 2 number 3's. Let's simplify. I have 2 number 2's, so that is 2 squared. Keep your multiplication sign. And I also have 2 number 3's. That's 3 squared. And there's our final answer. The second method you could use is the ladder method. Because we've been using the ladder method to solve for GCF and LCM, I thought we'd include this one as well. Now there's something very important if you choose to use ladder method. You must only use prime numbers to divide. If you use any composite numbers here on the side, that is going to make your answer incorrect. That's why I personally like the tree method better, because I can choose any two numbers to multiply. Whereas with this method, it must be prime numbers only. So see, we're back to this number 84 that we just worked with the tree method a moment ago. The number 2 will go into the 84 because 84 is even. Okay, 2 goes into 84 42 times. 42 is not prime, and so I need to continue. It is even. 2 will go into 42 as well. 2 goes into 42 21 times. 21 is not prime, so I keep going. When I add 2 plus 1, I get 3. So that means 21 is divisible by 3. So I put the 3 here. 3 goes into 21 7 times. Now once your bottom number is prime, you have found the prime factorization. 2 times 2 times 3 times 7. And then here it is simplified again, just like the last time we used the tree method. Let's try it out using the ladder method this time. So we will put the number 125 into our ladder. Because I'm looking for a prime number, I'll think of my divisibility rules. I see that this number ends in a 5. If a number ends in 0 or 5, it's divisible by 5, and 5 is prime. 5 will go into 125 5 times. 5 times 25 is 125. I'll need to continue my ladder because 25 is not prime. Alright, so now I'll need a prime number to go into 25. We'll use 5 again. 5 goes into 25 5 times. And now that I have a prime number at the bottom, I'm done. Rewrite 5 times 5 times 5. Alright, so since I have 3 5s, we'll combine them by putting 5 cubed. And that's our final answer.